Hello everyone, and thank you for viewing today's webinar. My name is Andrew Underwood, and I am the Dell EMC High Performance Computing Leader for Australia and New Zealand. Today I wanted to share our new Dell EMC Ready Bundle for HPC Lustre Storage and provide you with guidance on how this solution is positioned to help your customers accelerate their research and development and to help you exceed your quota. But before we get started, I wanted to take a quick moment to thank our training sponsor, Intel. To enable tomorrow's innovations today, we are introducing our Dell EMC Ready Bundle for HPC Lustre Storage. For many organizations, high-performance computing is now a competitive advantage that allows them to address complex research and product innovation challenges where speed to results matter. To push past this challenge, researchers, analysts, designers, and engineers are turning to high-performance computing systems to address their increasing complexity and time criticality. But the use of HPC is also generating massive volumes of data that put a strain on traditional modern storage platforms. This boom in data, much of it being generated via simulation or machine, Dell EMC has built a platform that will help you to unleash the extreme performance and scalability of the Lustre parallel file system for high-performance computing workloads, including technical big data applications, inside your customer's account. The Dell EMC Ready Bundle for HPC Lustre Storage allows end users that need the benefits of large-scale, high-bandwidth storage to tap the power and scalability of Lustre with its simplified installation, configuration, and management features that are backed by Dell EMC and Intel. The Dell EMC Ready Bundle for HPC Lustre Storage helps bring the benefits of high-performance file systems to a broad range of enterprise organizations. Dell EMC's enterprise-ready storage solution can deliver a high level of computing power and throughput and make available information and insights derived from big data and compute-intensive applications such as advanced modeling, simulation, and data analysis, to a wider audience of enterprise users. Our HPC storage solution offers the potential to drive discovery, deliver higher quality products and designs, and sustain competitive advantage. IDC tells us that on average, about 25% of the cost of a HPC system is dedicated to storage. Dell EMC's customers also tell us that HPC storage accounts for about 90% of their problems and administration time. Inadequate I/O capability can severely degrade the overall cluster performance, particularly in the case of HPC systems with over 32 compute nodes, which are doing simultaneous I/O. Storage administrators and researchers are also challenged with the growing burden of managing and monitoring complex storage systems. Development and maintenance of their environment, while crucial to the research being performed, are tasks which take time and focus away from the research which they're there to focus on. But overall, the biggest challenges facing HPC communities are getting the required performance, reliability, and capacity at a desirable cost in a solution. For HPC customers, I/O bottlenecks equal longer time to insight, and that equals lost revenue. Dell EMC has partnered with Intel to leverage the Intel Enterprise Edition of Lustre file system, and we've engineered a HPC storage platform to provide maximum throughput per building block with on-the-fly storage expansion. In high-performance computing, the efficient delivery of data to and from the compute nodes is critical and often complicated to execute. Researchers can generate and consume data in HPC systems at such speed that turns the storage components into a major bottleneck. Getting maximum performance for their applications requires a scalable storage solution. The Dell EMC HPC solution with Lustre is a true software-defined storage approach, and by leveraging PowerEdge R730 servers for file connectivity and front-end networking can be 10 gigabit Ethernet through to 100 gigabit Ethernet, or even InfiniBand or OmniPath architecture from Intel via the Dell EMC H series switches, which run at 100 gigabit and ultra-low latency. This high-speed networking connectivity coupled with the fact that Luster's object-based file systems with distributed striping across storage targets enables high throughput and low latency of the Dell EMC HPC storage solution with Lustre. Lustre is also designed to be highly available with no single point of failure, and has a global shared namespace accessible by over 25,000 clients for high-performance computing and technical big data workloads. As I mentioned in the previous slides, Lustre is a parallel file system offering high-performance throughput, parallel access to data, and distributed locking. A Lustre installation consists of three key elements: the metadata subsystem, the object storage subsystem, where the data resides, and the compute clients that access and operate on the data. The Dell EMC Ready Bundle for HPC Lustre Storage is a building block design built on Dell EMC PowerEdge and PowerVault modular disk hardware, as well as Dell EMC networking that provides redundant servers and failover-enabled storage. The results are a file system that is highly available with no single point of failure and scales with the simple addition of more hardware: PowerEdge R730s, modular disk MD3460s, modular disk MD3420s, Intel's Enterprise Edition of Lustre licensing, as well as scale-out Ethernet, InfiniBand, or OmniPath architecture networking fabrics direct to the compute nodes. The metadata subsystem is comprised of the metadata target, or MDT, the management target, or MGT, and the metadata servers, or MDSs. The MDT stores all the metadata for the file system, including file names, permission, timestamps, and the location of data objects within the object storage servers. The MGT stores management data such as configuration information and registry, and the MDS is a dedicated server that manages the MDT. In the Dell EMC solution, this is made up of PowerEdge R730s and SAS-connected PowerVault MD3420s for the metadata server, and the individual disks are the metadata targets. Network connectivity to this can once again be Ethernet, InfiniBand, or OmniPath. The object storage subsystem is comprised of one or more object storage targets and one or more object storage servers. The OSTs, the object storage targets, provide storage for file object data, while the object storage servers, or OSSs, manage one or more OSTs. Typically, there are several active object storage servers at any time. Lustre is able to deliver increased throughput by increasing the number of active object storage servers and of associated object storage targets, ideally in pairs. And as you can see on screen, the Dell EMC solution has object storage servers in pairs. These are two Dell EMC R730s connected in active-active, connected to via a SAS high availability connectivity to 4 MD3460s for the object storage targets. Once again, connectivity to the R730 object storage servers can be Ethernet, InfiniBand, or OmniPath directly connected to the compute network. Per building block, our Lustre storage solution can drive 18 gigabytes read and 15 gigabytes a second of write throughput on a 4 petabyte storage capacity. But as Lustre is a scale-out parallel file system, it can easily be grown in a 24/7 production environment by adding more building blocks or PowerEdge servers and PowerVault storage. There are many advantages to Lustre over traditional NFS. As Lustre is a distributed scale-out file system, it is designed to resolve a core issue in NFS storage. NFS is not scalable from a parallelized perspective, meaning that if in more NFS systems you can add more NAS heads, but it won't improve throughput or capacity overall, and it only adds high availability. Some file systems like OneFS will scale out when you add another NAS server. However, a client can only write to that Isilon array via that NAS gateway. This means that individual or multi-client performance is limited to the throughput of a single gateway server, or NAS head. With Lustre, as the files can be striped across multiple object storage servers, we can increase the performance by adding more object storage servers. On the Dell EMC storage with Lustre, a single OS pair would be able to write a file at that 18 gigabytes a second, and if we added another OSS pair, it would be able to double that read and write to over 30 gigabytes a second. This is phenomenal performance for very large files. Some Dell EMC Lustre deployments have dozens of OSS pairs and are writing at over 500 gigabyte a second today, and tens of petabytes of capacity. The concept of Lustre is actually quite simple. When a client requests to write a file to the file system, it contacts the metadata server with a file request. The MDS checks the user authentication and the intended location of that file. Depending on the directory setting or file system setting, the MDS sends back a list of object storage targets so the client can use to write the file. Once that reply is sent, the client interacts exclusively with the assigned object storage targets without having to communicate with the metadata server again. This is true for any file regardless of size, whether it's a few bytes or a few terabytes. Files on the Lustre file system can be striped, which means they can be transparently divided into chunks that are written or read simultaneously across a set of object storage targets within the file system. The chunks are distributed amongst the object storage targets using a method that ensures load balancing. Striping allows for one or more clients to read and write different parts of the same file at the same time, providing higher I/O bandwidth to the file because the bandwidth is aggregated over multiple object storage targets. Striping allows for file sizes larger than the size of a single object storage target as well. In fact, files larger than 100 gigabyte must be striped. As you can see on the screen, we've provided some basic workflows on how Lustre writes files and how Lustre reads files as well. It's a very straightforward 5-step process, both for writing and for reading, and involves the metadata server as well as the object storage targets, but importantly, the clients or the compute nodes. The actual distribution of files is defined by the specific striping setting of a file, directory, or files, or the file system itself. If the specific file write command does not have any predefined set of stripe settings, it will inherit the setting of the directory or file system to which it is written. The Enterprise Edition of Lustre can be driven via either the command line or via the Intel Manager for Lustre software dashboard, which you can see here on the screen. This is also known as the IML. The IML allows for the configuration, monitoring, alerts, and event information via a complete graphical user interface. Whether you're looking for insight to per disk or per array performance or utilization, or even adding additional nodes for capacity and throughput, this can all be driven through the IML dashboard to make adoption and ongoing management for Lustre seamless and simple. On the screen, you'll be able to see the images that show the sequential performance of the 960 terabyte test configuration of a base building block of our Ready Bundle for HPC storage with Lustre. With this test bed used, write performance peaks slightly over the 15 gigabyte a second, while read performance nears 18.5 gigabytes a second. Single client performance was consistent at around 1 gigabyte a second to 1.5 gigabyte a second for writes and reads. This is using EDR and directly connected omnipath networking, direct from the compute clients straight to the object storage servers and the metadata servers. The benchmark that you'll be seeing on screen now shows that the random write performance peaks at 256 threads with 17.5 thousand IOPS, with steady leveling after 24 threads, while random reads show a steady incline as threads increase. The IOPS of random reads increases rapidly from 4 to 32 threads, and again at 72 to 256 threads. As the writes require file lock per object storage target access, saturation is also expected. Reads can take advantage of Lustre's ability to grant overlapping read extent locks for part or all of the file. The latest version of Lustre, which Dell EMC uses in our Ready Bundle, now supports the Distributed Namespace Environment, also called DNE, which allows for additional metadata targets to boost performance of the environment as our customers' workload demands grow. One thing that you'll see from these benchmarks is that Lustre is built for high throughput environments. Typical workloads such as simulation don't generally generate very large I/O. Therefore, Lustre has been designed for throughput streaming performance first. To make sure that you've got a great ability to better understand the Dell EMC HPC solutions, as well as the Dell EMC Ready Bundle for HPC Lustre Storage, I wanted to make sure that you saw some of the links on the screen. There is an abundance of information on the HPC solutions that Dell EMC has architected, both internally and externally. I suggest starting out by heading to the Dell EMC Blueprints page on Sales Edge for legacy Dell and legacy EMC employees. The blueprints and white papers for the Dell EMC Ready Bundle for HPC Lustre Storage are also available on the HPC Blueprint page on the Dell EMC Public Tech Center blogs. These can be provided with our customers as well. In addition to this formal material, over 200 high-performance computing enthusiasts at Dell EMC participate in the internal HPC interest list, which you can subscribe to by emailing hpc-interest@dell.com. This is a great place to get started for high-performance computing. Whether you're in LATAM, EMEA, North America, or APJ, you can definitely jump on this HPC interest list, and people will work together as peers to guide you and guide your customers in the right direction. So, what's in it for you? The high-performance computing market is a $22 billion market, which is expected to grow to $30 billion in 5 years. That's over 6% CAGR. The bulk of this market is built around compute and networking, followed by software, storage, and services. However, customers in this space are looking for end-to-end solutions, or providers who can provide all of these components over the life of their system as they expand their investment. As HPC can be quite unique to each organization, our blueprint and bundle poses a great opportunity to penetrate acquisition accounts or growth markets for Dell EMC. HPC storage in particular can assist Dell EMC with attracting higher margins to our computer networking by focusing on the end-to-end solution in markets that demand extreme performance or scalability. HPC systems investment can start as small as $50,000 and grow up to over $100 million per customer, depending on the market and the size. So we want to help you capture this and exceed your quota. Next steps, we definitely recommend identifying HPC customers, qualifying your HPC customer opportunity by engaging your local HPC sales specialist. Then develop a HPC account plan and review some of the HPC benchmarks and white papers via the HPC Innovation Lab and the Blueprints page on Sales Edge. Feel free to share these with your customer and engage to win. Thank you for joining today's session, and good luck. And remember that quote from Michael Dell. At Dell EMC, we put the tools in the hands of the people who are going to solve the world's biggest problems. And our high-performance computing solutions are certainly here to help that. Thank you.